Again, good morning and welcome back to our channel. So this morning, I'm going to discuss a method of integration known as the algebraic substitution. Now this method of integration will be used when you're given contains an irrational integrand, wherein by substitution, this irrational integrand will be converted to in rational form involving algebraic terms. That is why we call this as algebraic substitution. Now, these are some of the kind of the algebraic substitution. First, we have the fractional powers of x. Okay? Now, as indicated below, so we can replace our u to the expression which is an intront of x. Or you can have our u to power n to remove your radical, so which is an intront of x. So we can raise to a power n both sides of our equation here. So to a power which is n, and that's equal to x, where n represents the least common denominator of the fractional powers of x. Now, example, if we are given and we are asked to evaluate the integral of a dx over the square root of x minus 2, cube root of x. Now, equivalently, pareho rasad ni siya, that we are given the integral of a dx over x to power 1 half minus 2 x to power 1/3. So, between the denominators 2 and 3 for 1 half and 1/3, the LCD of which is equal to 6. And that will represent your in value. So, what is the substitution to be made? So, you can let your u be equal to the 6 root of x. Okay? Or you can have u to power 6 which is equal to x. Now, we need to have our x here because in our given, we have a dx. And aside from that, we also have x to power 1 half, wherein we have to identify what expression can be a substitute of this in terms of our u. Now, if our x is equal to u to power 6, then we can take its differential. The dx of which, and the power rule is 6u to the 5th power du. Now, looking for a substitute of x to power 1 half. Okay? From x is equal to u to power 6, then raise this to a power 1 half both sides. So, x to power 1 half, and we have u to power 6, that is also raised to power 1 half. And the product of this, 6 times 1 half is equal to 3. That is why the square root of x, pwede na ito pulihan o u to power 3. Now, how about the x to power 1/3? So, raising this to power 1/3 both sides. So, x to power 1/3, and we have u to power 6, that's also raised to power 1/3. The product of 6 and 1/3 is 2. So, cube root of x, or x to power 1/3, is equal to u squared. So, we are now ready to substitute to the given. Okay? So, the integral of a dx over the square root of x minus 2 cube root of x is now equal to dx can be replaced by, okay, so we have 6u to the 5th power du. Denominator, the square root of x can be u cubed. And then minus 2u squared for the 2 cube root of x. The cube root of x can be replaced with u squared. Okay? So, basic to, in working with this kind of integrand, so constant factor can be placed before the integral sign. Now, as a fraction can be reduced to a Lewis term whenever possible. And how to reduce the Lewis term? So, we can look for a common factor that exists in numerator and in denominator. My denominator is factorable with a common factor of u squared. So, when u squared is removed, so we can obtain the u minus 2 as the other factor. Now, u to the 5th power and u squared, so this can be reduced because there's a common factor, or u squared also exists as a factor in u to the 5th power. So, removing your u squared, so we have the resulting fraction, which is u cubed over u minus 2 as our new integrand. Now, as a fraction, you always have to check whether the fraction is proper or improper. So, this is improper. So, if that's improper, so pwede ta mag-divide. Okay, so dividing the resulting integrand, u cubed over u minus 2. So, it's possible for us to apply the synthetic division. Okay, so just to recall, our synthetic division, if our divisor is u minus 2, then I can make use of my constant negative 2. But ang akong ibutang dire is the opposite of that constant, which is 2. The leading term is u cubed. Okay, so with the constant coefficient of 1, so all the terms must be there, and if the terms are missing, then you can provide with a 0 element for any missing term. U cubed followed with u squared, u to power 1 until you have the constant. But these terms do not exist in our fraction here. So you can have 1 from the coefficient of u cubed, but the rest have coefficient equal to 0, including your constant term. Okay, so this is the process of your synthetic division. You can bring this down, then you multiply to 2 or to your divisor, and go with the next column and add. That process is repeated. Then we can have 4, go with the next column and add, then you multiply, that's equal to it, you add, and the last element which is in red, no? So this is what we call as the remainder. Now, these are the constant coefficient of your quotient. Now, when you divide cube or an expression in cube or in third degree with a linear divisor, so there must be a reduction of a degree by 1 in its quotient. That is why, if this is your quotient row, then your quotient will start with u squared. Okay? So, this is how you rewrite. Okay? So, we have 6, and this is the quotient, correct? So, we have the integral of, so you can start with u squared because your dividend is in cube. So, 1u squared plus 2u, then plus 4. Then the last element is the remainder, so 8 over your divisor of u minus 2. Now, applying your formula of integration, this is in cube over 3. So, we have 6 divided by 3. So, we have the term which is 2u cubed. This one, this is in square over 2. So, 2 is eliminated, but I have 6 which can be distributed. So, I have 6u squared. This is 4 times 6, which is 24. The integral of a dio is u. Then plus, we have the product of 6 and 8. That's dio over u form, correct? So, that's 48 ln of u minus 2 plus c. This is expressed in terms of a dummy variable u. So, that's why we need to restore our variable x. Okay, so how to restore? If our u is known to be a 6th root of x, or that is equal to x to power 1 over 6, then again, our u squared, if you take the square, okay, so that's equivalent to a cube root of x. This is also identified earlier, okay, that the cube root of x is equal to u squared, and the square root of x is equal to u cubed. If not, so if you cannot recall that, then you can always go back here. So u cubed is the cube of x to power 1 over 6, then raised to power 3. So 3 over 6 is 1/2. That is why we have a square root of x. So you can now restore your variable. Okay, so we have 2 times the square root of x, which is 2u cubed, correct? The 6u squared is 6 cube root of x, that is the cube root of x, correct? And plus, this is 24u, and our u is a 6 root of x, correct? Then plus 48 ln of the 6 root of x minus 2 plus c as our answer. Okay, so that's how to work when you have a given like that. So, x containing a fractional power. Now, next example, we have x to power 3 halves over x to x plus 4 as our denominator. So, we have to integrate this. So, if your x has a power 1 dire, in the denominator side, while your numerator has a power which is 3 halves. So, the only denominator in the powers of x, because this contains an integer power of 1, kine, so this is containing 3 halves. So, the only denominator is 2. So, what's the LCD between 2 and 1? So, simply, we can have it as 2. So, your n is equal to 2, which is the LCD. That means, if we have to look for a substitute of, so we can let our u be equal to the nth root of x. So, or our u raised to power n is equal to x. Now, referring to our given, if our LCD is 2, then we can let our u be equal to the square root of x. So, ang atong u squared, if you take the square both sides, so that's equal to x, correct? Now, dx is the differential of this one. X is equal to u squared, correct? So, the differential of that is also equal to 2u du, correct? Then, I'm looking for a replacement of u of x to power 3 halves. So if my x is equal to u squared, so raise this to power 3 halves both sides, correct? So x raised to power 3 halves, u squared raised to power 3 halves. So the product of 2 and 3 halves is equal to 3. So that is why x to power 3 halves can be equal to u cubed. So I can now substitute to the given. So replacing my variable x in terms of a new variable u. So x to power 3 halves can be u cubed, correct? Then x, what is x? X is equal to u squared, okay? Then plus 4. So 2 can be placed before the integral sign as a constant. Then I can take the product of u and the u cubed. This is u to the 4th power. Divide with u to power 2 plus 4. So again, this is an improper fraction. So I can divide, but I'm not going to apply anymore synthetic division because my divisor is in second degree. Okay? So, how to divide? Okay, so we have u to the 4th power with u squared plus 4. Okay? So, again, you have the first term which is u squared. You go back to your divisor. You multiply. You distribute your divisor. You have u to the 4th power plus plus 4 u squared. Then we subtract. Okay, so this is eliminated. This is changed to its opposite. Okay, so minus 4u squared. Still, this can be divided because the degree are the same. No? So, minus 4u squared divided by u squared will give you minus 4. Then you can go back. Minus 4u squared minus 610. Then again, you subtract. This is eliminated while I can change this to opposite. The degree of which is 0 being a constant. So, this will serve as a remainder. Okay? So, I can give my quotient and my remainder over the original divisor. Quotient is R. Then we have plus 16 over u squared plus 4. So I have to apply integration. The integral of which the first term I meant is applying your power rule is u cubed over 3. Okay, so there's 2 before. Okay, or we can multiply that with 2 later. Okay, so this is 4 times u or negative 4 times u. Correct? This is 16. And according to a formula, du over u squared plus 4. So, actually, we have the formula which is 1 over a arctan of u over a. So, what is our a? That is the square root of 4, which is 2. So, 1 over 2 as 1 over a. And arctan of u, the square root of your u squared. So, over a. So, u over 2, then plus c. Then, you can restore your variable. Or you can also distribute your 2. Okay, so there you have your answer. U cubed, where is our u cubed? That is equivalent to x to power 3 halves, correct? Then minus 8 when we have 2 distributed to 4, right? Okay, so our u is the square root of x, correct? We have the square root of x, then plus 16. That's 16. Okay. So, this is 8 times 2. So, that's 16. Then, arctan. Arctan of the square root of x being our u over 2 plus c. Okay, so that's how to work when your given contains fractional power of x. Now, another kind of substitution is when we have this. A substitution which is equal to u in truth of ex plus b. By the way, this is linear radicand, correct? So, or you can have your u, which is equal to ex plus b raised to power, which is fractional, which is 1 over n. Okay, so if you want to remove the fractional power, then you can have your u be raised to power n, which is equal to ex plus b. Because we need to have an integrand which is no longer irrational. So, if we want to remove an irrational expression in our given, then we can raise this to power n both sides. So, our n is the LCD of the fractional powers of ax plus b. So, that is if there are several terms involving ax plus b containing different powers. Okay? So, given. We are asked to integrate x, the square root times the square root of 4 minus x. Now, good, because there is only one linear expression that is raised to a power of 1/2 or a square root of 4 minus x here. So, we can follow the indicated substitution where we can replace it with u. U is equal to this radical expression. That is equal to the square root of 4 minus x. As I've said, in order to remove the radical or to free my given with radical expression, then I can take the square both sides. Okay, u squared is equal to 4 minus x. Now, I'm looking for a substitute of x also. My x, if solved out from this equation, is equal to, I'm bringing my x there, and I can associate my u squared with 4. So, x is equal to 4 minus u squared. Dx, if substituted, if I'm looking for a substitute of a dx, so the dx is the differential of this equation. Dx is equal to, this becomes 0, minus 2u du. Correct? Okay. Now, by the way, if our given is definite integral, so what are you going to do? You can also change the limit of integration now before you integrate together with the changing of variable. But this is a case where we have the indefinite integral, so we are now ready to substitute. Okay? So, x can be replaced. Masay puli na to sa itong x. We can have it be replaced with 4 minus u squared. This is actually your u. Ganina. And your dx can be minus 2u du. Okay? Putting your minus 2 before the integral sign, being a constant, this is a product of u times u, which is u squared, which can be distributed to the terms of our binomial factor. Okay? So, what is the result? So, there, I have 4u squared minus u to the 4th power when that's distributed. And I can integrate. First term becomes u cubed over 3 under a power rule. The second term is u to the 5th power over 5 plus c. Now, before you restore the variable, it's good to simplify this first by maybe removing a common factor. What's common factor here? The common factor in your u is u cubed, correct? And I can take the LCD of 3 and 15. What's the LCD? That is 15. Okay? So, I take this common factor together with the constant. So, outside is minus 2u cubed over 15. How to get 20? So, you can have 15 divided by 3. What is 15 divided by 3? That is 5 times 4. That is why I obtain 20. So, u cubed is already out. So, I only have a constant term in my first term. Now, 15 divided by 5 is 3. Correct? Okay, so we have 20 minus 3. And there is still u squared that is left because what is being removed is only u cubed. Then we have plus c. Then we can now restore our variable. Okay? If our u represents the square root of 4 minus x, and that is u cubed, that means the square root of 4 minus x will be raised to cube. Correct? That's over 15. Then we have 20 minus u squared, and our u squared is 4 minus x. So, there are terms which are similar. We have the constant term, which is 20 minus 12. That's why I have it. This is 3 times x. Both are negative. That is why I have a product of 3x. So, this is now your final answer. Okay? So, last is we have the integral of a ratio where we have a numerator which is 4 minus the square root of 2x plus 1 over 1 minus 2x. So, this is the only radical expression, a rational term in our given. So, we can have it as u equal to, what is our u? That is equal to the square root of x, 2x plus 1, I mean. U squared is 2x plus 1. Now, there is an expression of 2x in the denominator. So, if my 2x is solved, then 2x can be equal to u squared minus 1. Differentiating this equation will give you 2 dx, correct? And that's equal to 2u du. Okay? Removing 2 as a common factor, so my dx, this is dx, sorry. My dx here can be equal to u du. That's dx, okay? So, sorry. So, wala ko ma-appeal ang differential in x. So, x lang ako nabutang. Okay, so we have a dx which is equal to u du from this equation. So, substitute to the given. So, we have 4 minus u. This is u, correct? Then minus 2x can be, okay, so we have 1 minus 2x, and my 2x can be u squared minus 1. Okay? Now, this is equivalent to, what is that equal to? This is 4 times u when you distribute. This is minus u squared. Your denominator is the sum of constant. This is 1 minus a negative 1. That's 2, correct? And that's minus u squared. This is arranged in ascending order, correct? So, I may start with the highest degree term to arrange my expression in a descending manner. Removing a common factor of minus 1 from the numerator and denominator side. So, there I can start with u squared, and this can be minus 4 times u, correct? Denominator, removing a minus 1 factor, so you have u squared minus 2. Both are negative, yeah? So we can have this be removed, and this expression is also equivalent to the integral of u squared minus 4u over u squared minus 2. Again, what kind of fraction do we have? They have the same degree. So if they have the same degree, so before you integrate, then you can also divide. So divide first, u squared minus 4 times u divided by u squared minus 2. Okay, so u squared with u squared, that's 1. So distribute u squared, so minus 2. So I take another column for a constant because this is a u term column, no? So we have the minus 4u when you subtract, correct? Bring this down. Then you change the sign of your subtrahend to its opposite. So this is in first degree while our divisor is in second degree. So meaning this is our remainder, correct? Okay, so this is how we write. Okay, so this is now an integrable form, no? So we have 1, the quotient, plus the remainder of minus 4u plus 2 all over u squared minus 2. By the way, if our divisor is quadratic and we have to solve for its du form, the du of this is 2u du. In your numerator side, we have a first degree term and a constant. So we can separate this into two parts. Okay? So we have the minus 4u du over u squared minus 2 to make it integrable under the I5 or a du over u. Now, the second term is 2 over u squared minus 2, wherein this is actually purely quadratic, and this can be evaluated under a different formula. Now, before we integrate, no, so if this is our u, so our du is 2u du. So this is lacking with 2. That is why I'm providing to her, and I neutralize with 1/2. Okay? So here, our u is u, and its du is there. So this is already an exact differential of what formula itong gigamit. So this is du over u squared minus a squared. By the way, this is covered according to our numbering. So this is covered in I-22 prime. Okay? So integral of this is u. If that's du over u, then that is minus 2 because we have half of 4. Minus 2 ln of u squared minus 2. Then this is from 2, and this is now the application of the formula and the integral of a du over u squared minus a squared, which is 1 over 2a. If this is our a squared, our a is the square root of 2. So it's 1 over 2, then times a. ln of u minus a, which is u minus the square root of 2, then u plus a, which is u plus the square root of 2 plus c. So what is needed, what is lacking here is to restore our variable. Our u is equal to the square root of 2x, correct? Okay, so we have the square root of 2x when we restore our variable for our u, then minus 2 ln. This is u squared, and where is our u squared? That is 2x plus 1. So it is 2x plus 1 minus 2. So I go directly with the equivalent. So this is 2x plus 1, then minus 2. That is why I have the 2x minus 1 when I have 1 and minus 2 combined. Correct? Okay, so 2 over 2, that's eliminated. So what is left is 1 over square root of 2. ln of the absolute value of our u, which is the square root of 2x plus 1 minus square root of 2. Then, again, we have our u, which is the square root of 2x plus 1 plus the square root of 2 plus c. Okay? So that's all, and thank you for watching. So bye bye and good day everyone.